Good day everyone. Today we will explain how we can locate a missing vessel and determine the height of a lighthouse using basic trigonometry and navigation principles.
So, we are tasked to act as navigational officer responding to distress signal for missing vessel. In this scenario, two ships, ships A and ship B, are trying to locate the exact position of the missing vessel using angle of distance. This problem shows how mathematics, especially trigonometry, is applied in real-life maritime navigation. By forming a triangle using the position of the ship and the angles observed, we can determine the exact location of the missing vessels. We are also compute the height of the nearby lighthouse using the angles of elevations, and also we will identify which quantities are scalar or vector.
Let's begin with the given information. Ship A and Ship B are 8 nautical miles apart. Ship A detects the missing vessel at angle at 45 degrees, while the Ship B detects at 60 degrees. Using the information, we form a triangle where Ship A and Ship B are at the base. The missing vessel is at the top. To complete the triangle, find the third angle since the sum of angle at triangle is 180 degrees. We subtract 45 degrees plus 60 degrees equals 105 degrees. So the remaining angles is 75 degrees. Now, we have a complete triangles which is can use to solve for distances.
Solving using law of sine. To find the distance from each ship to the missing vessel, we use the law of sines. Side over sine of its opposite angle is equal to other sides over the sine of their angles. One side is 8 nautical miles, and all three angles are 45 degree, 60 degree, and 75 degree. After solving, the distance from ship A to a missing vessel is approximately 5.86 nautical miles. The distance from the ship B is approximately 7.17 nautical miles. This value tells us exactly how far the missing vessel is from each ship, allowing rescuers to locate it accurately.
Now, let's move on to the second part of the problem, the lighthouse. Ship A observes lighthouse at an angle of elevation of 30 degrees and the horizontal distance of the lighthouse is 6 nautical miles. We form a right triangle where the base is 6 miles, the angles is 30 degrees, the height of the lighthouse is what we are solving for. Using the tangent function, tangent of the angle equals height divided by base. After solving, we get the height of lighthouse is approximately 3.46 nautical miles. To convert this into meters, we multiply by 1,852 meters per nautical mile, giving us approximately 6,409 meters.
Next, we identify scalar and vector quantities in the situations. Scalars are quantities with magnitude only. These include distance like nautical miles, lighthouse height, and angle shot as 45 degree, 60 degree, and 30 degree. Vectors, on the other hand, have both magnitude and direction. This includes the vessel from ship A to the missing vessel, the direction from ship B to the missing vessel, the directions toward the lighthouse. Understanding this difference is important in navigation because directions plays a key role in locating objects at sea.
In conclusion, in real-time maritime navigator, these calculations are very important. Navigators often rely on angles and distance to determine the position, especially when GPS is available. By forming triangles and using trigonometric function, they can accurately locate vessel, avoid hazard, and ensure safe travel. Similarly, estimating the height of the object like lighthouse helps in identifying landmarks and improving visibility awareness. To conclude, we use triangle geometry to locate the missing vessel, apply trigonometry to calculate the lighthouse height, and identify the scalar and vector quantities. This activity shows how mathematics is essential in real-life maritime operation. Thank you for listening.
So in this part, we will show you the ship A, ship B, and the missing vessel, and we will show you how to locate the missing vessel. So as you can see, this is ship A and this is ship B. So this you can see, this is the missing vessel because there is a question mark. So the steps to follow when locating the missing vessel. So you need to turn to the other page. So this, you need to pull this in order to know the steps to follow how to solve the missing vessel. So this is the first part. As you can see, we solved the missing vessel step by step, and this is the second, finding distance. So using the law of sines, and this part is the continue of that part. So here we show you the result of our calculation on finding the missing vessel and convert it to meters. So our result distance from sine A is 60,850 meters. So that's it. So in this part, you will ask if what's this. So this is the lighthouse. So this shows the angle of the ship from the ship to the lighthouse. So the angle is 30 degrees. So when you want if you want to know the result by using the trigonometry, you need to pull this part. First is the let me pull this. So as you can see, ship A observes a nearby lighthouse at an angle of elevation of 30 degrees with a horizontal distance of 6 nautical miles. So you can see that is 30 degrees and the distance from ship A to the lighthouse is 6 nautical miles. So next you need to pull the second step. This is the second step. So this is the lighthouse height. Trigonometry. The given is the angle of elevation is 30 degrees. The horizontal distance is 6 nautical miles. So using tan equals height divided by base. So equals height equals 6.tan 30 degrees. So the height is equals to 6.07.577 equals to 3.46 nautical miles. So you need to pull the third and the last part. So convert height to meters. So 3.46 nautical miles times 1,852 is equals to 6,409 meters. Lighthouse, so the lighthouse height is 3.46 nautical miles or 6,409 meters. So that's it, guys. Thank you for watching. Sorry if it's not that creative, and thank you for listening.